Hi everyone, my name is Leandro Gomes. I'm a PhD student at Nova School of Science and Technology, and I'm here to present you the prospects of cultivating giant weed and switchgrass in heavy metal contaminated soils. The reason why we are doing this, why we are studying this, is because in the European Union we cannot cultivate industrial crops in lands that are suitable for food and feed crops. So we are cultivating industrial crops in marginal lands. Marginal lands are lands that have a little or no potential at all for profit. And this is due to the conditions, usually the conditions of the soil, because the soil has no nutrients or a low amount of nutrients, a lack of water supply, weather conditions, or the presence of contaminants in the soil. So, which kind of contaminants can we have? Well, one of the biggest problems are the presence of the heavy metals in the soil. And do we have a lot of this in Europe soils? Well, as you can see here, we have for copper, zinc, nickel, cadmium, and lead, the maps indicating the spots where the level, the concentration of these heavy metals in European soils are high. And if we put these maps one on top of the other, we can see that a big part of European soils are contaminated with at least one heavy metal. So to cultivate a crop in this metal, we have to choose well the crop. Must have high productivity, high energy content, high tolerance to stressful conditions, low need of inputs, water supplies, pesticides, herbicides, things like this. And we may have to use this biomass later. Okay, so we choose among the perennial crops that fulfill these characteristics. We choose Arundo donax or giant weed, as we know, and Panicum virgatum or switchgrass. Here is the design experiment. We use 6 heavy metals: zinc, chromium, lead, cadmium, nickel, and copper. And these are the following concentrations in milligram of heavy metal per kilogram of soil. We did this during 3 growing cycles. We have some results for productivity. We can see that Arundo donax productivity, that switchgrass productivity was higher in the third year. The reason for this is that the root system was get established during the first 2 years, during the first 2 growing cycles. In the third year, we can see it achieved its full capacity and the plants grow well. And we can see here that the biomasses, the contaminated trials were severely affected by the presence of the heavy metal, especially in zinc, cadmium, nickel, and copper. As we see, the reduction, the losses were around 50%, while lead was less. Chromium, on the other hand, we didn't have any biomass at all. For Arundo donax, we can see that the first 2 years, the crop grew well, and in the first year, chromium and nickel was severely affected by the presence of the contaminant. In the second year, we got zinc, lead, cadmium, nickel, and copper affected by the presence of the contaminant, but not so much. And a critical condition for chromium. Although in the third year, only chromium and lead showed a higher decrease in productivity when comparing to the third year control. Now, if we see the experiment, if we see all the experiment productivity at once, it will be like this. So we have the Arundo donax experiment productivity starting better in the first year, decreasing a little bit in the second year, and decreasing a little bit more in the third year, but the contaminated trial were not so affected as the switchgrass. In switchgrass, we have the increase of productivity, but we have the contaminated trials really affected in the third year, especially zinc, cadmium, nickel, and copper. If we analyze now the ash content of the biomass, we can see that during these 2 years, we got a reduction of ash content from the first to the second and the second to the third year for switchgrass, but all the contaminated the zinc, cadmium, nickel, and copper had a higher ash content when comparing to the control. On the other hand, Arundo donax, we analyze the stem and leaves, and we can see that the ash content was higher in the leaves than in the stems, and that basically for almost all trials, the presence of the contaminant indicated an increase in the ash content. And this is important because if we use these crops in a thermochemical process as combustion, for example, we'll have ash as a residue. So the more ash we have and contaminated one, the more we have to treat and discard. Another parameter that we analyzed was the high heat value. We can see here that for switchgrass, the high heat value increased from the second to the third year, which was the year that we analyzed. And considering the stems of Arundo donax, we can see that it decreased from the second to the third year. Despite this, for both biomasses, the presence of the contaminant in all trials indicated a decrease in high heat value. So when we analyze productivity, ash content, and high heat value, all at once, we can see if a crop is suitable for thermochemical process or not. For example, if you have low productivity, high ash content, and low heat value, it's not. And we have some cases here. Okay, for example, chromium. We have for stems of Arundo donax chromium, we have a lower high heat value, a higher amount of ash, and a lower productivity. We've indicated that to get the same amount of energy as we got in control, we need a bigger land of chromium contaminated Arundo donax, and we have to treat more ashes, and we will get a lower energy production. So it's not too much interesting. Taking these three considerations, I make this analysis, we concluded that, as we saw, despite the higher productivity, switchgrass than Arundo, when compared to Arundo, switchgrass was more affected by the presence of the contaminants. Arundo donax showed tolerance to the contaminants, but the productivity was lower than the switchgrass in the trials. And considering the three parameters altogether, we can see that to cultivate perennial crops in contaminated soils to use, for example, for thermochemical process, switchgrass is a better option than Panicum virgatum, than Arundo donax. Thank you for your time. You can contact me through email, through LinkedIn, and I'll be glad to answer all your questions. Bye-bye.